everybody, it's Jason back at you with another exciting video. So today we're going to do something different. We're going to talk all about plasma. Plasma cutting, plasma torches, cutting with plasma, tips and tricks using plasma. What's the difference in a pilot arc and a non-pilot arc? Which do you really need? What's the difference in this torch and this torch? We've got a lot to talk about, so I've got 3 fresh batteries for my camera, and so let's get started. Hey, before we get started, are you subscribed? Do me a favor. I put a lot of effort into these videos. Please subscribe, give me a thumbs up, leave a comment, share it with your friends. I would really appreciate it. And if you're learning something and you like what I'm doing, don't be afraid to hit that super thanks button and buy me a cup of coffee. So if you've been shopping around for your plasma cutter, you've been looking at these machines and you're seeing cut 30, cut 40, cut 50. Some of them have a P, some of them don't. Some of them have a DP. What does all that mean? Well, in front of me, I have 2 machines, and this isn't a comparison video. I just happen to have 2 machines here that I can show. This is my Prime Weld Cut 50 DP that is well used and I've had for quite a while. This is the Vevor Cut 50P that they sent me about a week ago to do a review on, and you may want to watch that video also. But what these mean are, you'll see cut 30, cut 40, cut 50, cut 60. That 30, 40, 50, 60 refers to the maximum amps that these machines will put out. Okay, so a cut 50 like these, the maximum output on 220 will be 50 amps. And the reason why I give that little caveat is most of these little machines, when you're plugged into 110, the maximum that you can expect from them is probably about 35 amps. And you know, 35 amps is not bad. I mean, that's plenty enough for cutting sheet metal, 1/8 inch, expanded metal, maybe anything up to maybe somewhere between 1/8 and 1/4. If you're wanting to cut 1/4 inch or higher, you're gonna have to plug into the 220 volt input so that you get the maximum or the 50 amps that these machines are rated for. Luckily, most of these machines that are coming out nowadays are the IGBT inverter style machines, and they will run on both 110 or 220, and they will usually include in a little adapter like this, so that you would take your, you would take your 220 plug it into this, and you can plug this into 110. If you don't want 110 and you want 220, you just pull this plug off and plug this straight into your 220 outlet. Now, this Prime Weld machine is called a Cut 50 DP. The D, I suspect, is signifying that it's dual voltage, which again, most of the machines that you're going to come across nowadays are going to be dual voltage, 110 or 220, and most of them, not all, but most of them, you don't have to switch anything on the machine to tell it that you're plugging into 120 or 110 or 220. You just plug it in. However, make sure that you check your machine, because I think there's one made by Harbor Freight, maybe, that you have to move a little switch on the back to tell it that it's 220. But again, check your machine, make sure you know how to operate your machine so that you don't blow it up. That would not be a good thing to do. Okay, so other than the differences between a cut 30, cut 40, cut 50, cut 60, whether it's dual voltage or whatever, there's another letter, it's the P. And if you see on here, this is the cut 50P on this Vivor model. And on this prime weld, it's a cut 50 DP. And again, I'm not 100% sure, but I suspect that the D on this one stands for dual voltage. But the P stands for pilot arc. And we're going to get into that in just a minute. But if you're expecting pilot arc functions and you buy a machine that just says cut 50, it's not going to have it. One of the dead giveaways, if it doesn't say P, which 99.9% of the time it will say P because it's just part of their marketing. But look for this outlet plug right here. There's one on here and there's one on here. This is the extra wire that goes into your torch lead that you have to have hooked up for the pilot function. So if you don't see this or this, it's not a pilot arc machine. So before we get into the differences between pilot arc and non-pilot arc, it's important that we have a good understanding of the different kinds of torches. This model right here, this is an AG60 style torch, and it is generally always going to be for pilot arc. And you can tell that because it's got this extra little wire with the ring that will go onto those lugs in the first segment that I showed you just a minute ago. This is a PT31 style torch. It is not a pilot arc function torch, but they both have the same two-prong switch connection, and they both have the same air connection. Now, when you buy a replacement torch, whether it's from the manufacturer or if it's from Amazon or whatever, generally these two connections are going to be the same. Look at the pictures and make sure. These are pretty much always going to be the same. Again, look at the pictures and make sure. Now, all that these do is make a connection with the trigger switch. So it's just on off. There's no, up top side or bottom side or anything like that. But you do want to make sure that it's 2-pin. If the connection on your box is something other than a 2-pin, you're probably going to have to order that torch from that manufacturer. But it does have a little divot right here on each of them, and all that does is make sure that when you plug it into the box that it's oriented the correct way. But again, AG60 is a pilot arc torch, and it will have the extra wire with the ring to put onto the pilot arc output plug on your box. The PT31 does not have it. So whether you're using the AG60 or the PT31, they both come with what's called consumables. Consumables are parts of the torch that get burned up in use. That's just normal. If you're flux core or MIG welding, that wire on the spool, that's a consumable. If you're arc welding, your stick electrode that gets burned up as you use it, that's a consumable. Same thing goes with these torches. Now, I've split these in half because I want to show you the differences in the AG60 and the PT31 and what makes them different. All right, so first of all, they both have what's called the electrode. On the PT31, it looks like this, and it's kind of a double-ended electrode. What's good about that is if you use up one end, you can just turn it around and use the other end. That's pretty cool. All right, the AG60 has just a single-ended electrode that screws in, and both of them, I don't know if you can see, let me see if I can get it to focus here. Well, it's not gonna do it. But if you look right here at the end of the electrode, there's a little silver dot. And you have one on the AG60 also. It's a little silver dot. And what that is an element called hafnium. All right, hafnium is an element that comes from the same place as zirconium. And they actually still use hafnium to make control rods in nuclear power plants. When that nuclear power plant in Japan was wiped out by that tidal wave or a tsunami, they needed a lot of hafnium to make more control rods, and the price of hafnium in 2014, when that happened, doubled. But that was a long time ago. Maybe it's settled back down or whatever. But what hafnium does is when you pass a current through it, it freely gives off electrodes. Okay, when it gives off those electrodes, the current going through these elements makes the end glow. The hafnium starts shedding off electrodes, and your air supply going through that carries those electrodes out, and that's what makes your plasma cut. All right, so we know that plasma is the fourth state of matter, and it's that supercharged, superheated flow of air that is actually making the cut. And since that air is electrically charged, that goes into your metal, bypasses the metal, makes the cut. But when it goes through that metal, that's what continues the circuit to your ground clamp. That's how it makes its circuit, is through that heavily ionized flow of air. Okay, on the PT31, it's real simple. You have your electrode, and then you have this little ceramic ring that's called the swirl ring, and you put that on there like that. This goes, it just sits down into your torch. Okay, let me see if I can turn that where you can see it. That just sits down on there, and then you have this. This is called your shield, and you can put that on there, and then the ceramic cup goes on there, and you screw it down. Now, I want you to see something. You see the distance that this comes out of there? This is one of the reasons why I favor the PT31, and you can use a PT31 torch on a machine that does pilot arc. You won't have pilot arc function, but you'll have this piece sticking up, and this is really, really handy for when you're trying to cut out, if you're using like a stencil. If you go on Amazon, you can find lots of metal stencils that you can use to make those oval cuts. Like if you're going to make a bumper or a trailer that's got those oval stoplights. They make a stencil that you can just place on there, and you use this to just go around that stencil like this. It's pretty handy. It's a little bit more difficult to do that with the AG60 because it doesn't stick out as much. Also, I want to show you on the PT31, these electrodes are available in 2 different lengths. See if I can show you that. See those differences? One's short and one's long. And if you use the short one, make sure that you use the short shield. Make sure you use the short shield and not the long shield, because you see that difference. So if you're going to use the short one, you'll notice that doesn't stick out nearly as far as it does when you're using the long one. See the difference that makes? It's almost 1/8 of an inch or so. But if you're going to use the long shields, make sure that you're using the long electrodes. If you use the short shield, make sure you use the short electrodes. And then all of your consumable kits will also come with these little white ceramic swirl rings. Okay, so it's a little bit different on the AG60. It has a semi-permanent swirl ring that's already down inside there, and it may be replaceable, I'm not sure. But over time, as you use your consumables, as you use them up and they burn up, keep checking your torch end. Let me see if I can show you this one. Let me get it to focus here. Yeah, it's not going to focus on that. But that fella right there is pretty eaten up. And you don't want it to get to that point. So keep an eye on your consumables. Every day after you use it, take it out, inspect it, see if it needs to be replaced. And do that before you use it to see if you need to replace it before you use your torch, or your results are not going to be very good. On the AG60, you don't have a swirl ring that you drop in. You just take your electrode. Your electrode is threaded on one end, and it just goes in the hole, and you twist it in. Okay. I'm doing this upside down, guys, so it's kind of hard to show this. All right, and then the next step is you take the shield. The shield goes on, and it screws on. And then you have the ceramic cup. It goes on, and it screws in. Okay, let me do the PT31 real fast. So you drop that in, take your swirl ring, put it on, then you take your shield, put it on, and then you take its ceramic cup and you put it on, and then you screw that together. All right, one of the dead giveaways, whether it's a AG60 or a PT31, PT31 torches are always going to have a white cup, and usually a copper colored shield coming out of the top like that. And the AG60 is almost always going to have a pink cup and a cone shaped shield. See if I can show that. See the difference? This one is the AG60. This one is the PT31. This is pilot arc. This one is not pilot arc. But again, you can use a PT31 non-pilot arc torch on a machine that has pilot arc. You just won't have the pilot arc function. And 90% of my operations, I'm using this torch because I like the long standoff. Also, let me see if I can show the bottoms of these. See if that'll focus on that. See those little cross hatches there? What these do is it gives a little path for the dross and the hot air to escape. This PT31 will normally be a contact tip, which means you're normally going to use it touching the metal and dragging it. Okay, it's also called a drag tip. When this piece contacts the metal, that's what makes its connection. With the AG60 or the pilot arc, that arc is created inside here, inside this. So when you pull the trigger, and I'm going to show you this in a minute, when you pull the trigger on a pilot arc, it's automatically going to shoot out about this far, whether it's touching the metal or not. Okay, and that's really handy when you're cutting something like expanded metal. And I'm going to show you that here in just a few minutes. With this kind, you're generally going to have some sort of a standoff, whether it's this kind or these little wire baskets. A lot of guys don't use these simply because whoever invented these made them tremendously difficult to get on and off the ceramic cup. And if you see there, it's got that little groove. So this little ring has to go in that groove. And this is very tight and very hard to do. These kind are basically the same way, but they just kind of snap on and it's just a pressure fit. And all these do is like this kind, or if you're using the kind that's got the wire basket, what this does is it's keeping that contact tip about that far off the metal. I'm sorry, I'm trying to turn this so that you can see it. It keeps that contact tip off the metal because with this kind, you don't really want that to touch the metal because all that does is just clog up the little orifice right there, and then you get a really bad cut. But again, this is the AG60 for pilot arc. This is the PT31 that's not a pilot arc, but you can use it on either machine. You know, Sundays are my only day off, and because I work all day on Saturday, these videos, I try to make one every Sunday. So while you're enjoying your weekend off, spending time with your wife or your girlfriend, your kids, your dog, fishing, hunting, whatever, playing on your hobbies, I'm in here in my studio making these videos for you. So please give me a thumbs up. Let me know that I'm making a difference and that somebody's learning something. I would really appreciate it, and because these videos take a long time to make. There's several retakes. You got editing that you have to do, then you have to upload it to YouTube, and then you have to do all the YouTube stuff in there on the keyboard. It takes the entire day, my entire day off, I spend making these videos for you. So I would really appreciate it if you would give me a thumbs up, share the video with a friend of yours, leave a comment down below, hit that notification bell so that you know when I make another video. And I've got some more giveaways coming, so you're not going to want to miss those, right? No. Okay, so let's talk about the air requirements to run a plasma cutter. Uh, as you can see, these just run on air supplied by your air compressor. It doesn't run off of any exotic gas like argon, carbon dioxide, or MIG gas, or CO2 mix, or anything like that. Just regular air that comes from your air compressor. Um, Almost all of these little machines like this, unless it's got its own built-in air compressor, like some of the Hobarts or the Hypermax, or Thermo whatever. Most of them are going to have an external air regulator on the back. This one happens to have the gauge on the back, which I wish it was on the front. This one is the prime weld. It's got the regulator on the back, but it's got the gauge on the front. All of them work basically the same way. You pull this up, you pull these up, and you turn it to what you need, and then you push it back down to lock it. For the longest time, I ran this one on a little Harbor Freight small air compressor, and I'm going to try to show the picture here. But I also have another business called All Star Compressors, and I build air compressors and truck mounted compressors for people, custom built. So the differences in those, you can run one of these little guys on a little air compressor. The only thing that you really need to know is what the supply requirements are on your machine. All right. Some of them might say it requires 4 cubic feet per minute, or CFM. If you look at the chart or the specs on your air compressor, a lot of the times it's going to say it will put out this much air at 90 psi. Maybe it's 5.2 at 90 psi. Well, you're not going to run these at 90 psi. Most of the time, you're going to run these little guys on maybe 40 to 60 or 40 to 60 psi is about all you need. Now, where that comes in for the little machines, you might have enough air supply to deliver a cut that's going to be maybe 6 inches, 6-7 inches, and that's plenty enough for a lot of people. And then you have to wait for that tank to build back up pressure until you can start cutting again. If you're using a big machine like this one that I'm going to try to put a picture on, that's 10 cubic feet per minute, but it's an 80-gallon tank. And so you have more air to make a longer cut or use it for a lot longer time. But when it finally has to kick on to fill in the tank, you're going to be sitting there for a while, because my big compressor, it takes a few minutes to fill it up, where a small compressor will fill back up in just a matter of a minute or so. But again, look at the specs that is listed for your machine. Look at what the CFM requirements are. Generally, you can get away with around 4. But again, look at your air compressor and see what it takes to do 4 cubic feet a minute. A lot of them will say 4 cubic feet at 90 psi, But if you're running it at 40 to 60 psi, that's going to be a lot lower, so it may not work out for you. Just make sure that you check it. Whatever it says at 90 psi, if you're running it at 40 to 60, that cubic feet per minute delivery is going to be a little bit higher. So this is the compressor that I currently use. As you can see, it's All-Star compressors. This is a 3 horsepower, 145 psi, 10 cubic feet per minute at 90 psi. And it does use a belt drive pump, a 3 horsepower motor, and it's a Haas. And it'll do it. It'll run any tool I have in the shop, and it has no problem running these plasma cutters. But again, you don't have to have a big one like this. If you're interested in one like this, look at there. I make them. Now, I've got another build that I've got coming up in a few weeks. The guys ordered a custom truck-mounted air compressor with a gas motor. And if you're interested in that build, let me know. I'll make a video about the whole build from start to finish so that you can make one of these also. Okay, so let's do some cutting. So before we start, let's talk about some safety. Make sure you're wearing some protective clothing. You got some gloves, and I always use a number 5 face shield. Okay, so for this example, we got some 1/4-inch plate, and I'm using the Prime Weld Cut 50 DP on 220 volts, and I'm using the PT31 torch without the pilot arc. And I've got a confession to make, and you're probably going to laugh at me about this. Do you remember a couple minutes ago I showed you the inside of this? That's because I got in a hurry one day and I was trying to use this, and I did not have my air hooked up. So I was sitting there squeezing the trigger. The arc was making on the inside, but there was no airflow to push anything out, and it burned up the inside of where the electrode seats into the gun. And so my electrode is actually sitting at a little angle, so my cut's not going to be directly straight up and down until I replace this. But don't laugh at me too hard. So what I'm going to do is I'm going to use this piece of angle iron as a straight edge. Now you want to make sure that you're not cutting like this, or you're not cutting like this. Make sure that you're straight up and down, and look at how you're twisted this way also. Make sure that you're straight up and down this way and this way. Let's go ahead and cut. So again, it's not straight up and down because my electrode is at an angle. But I do want to show you a little tip. See all this blob of stuff right here? That's called dross. It's really easy to clean up with just a hammer. All you got to do is just tap that bottom edge and that stuff drops right off. You don't have to sit there and wail on it with a screwdriver or try to grind it off or anything like that. Just a couple light taps with your hammer, it's gone. But that's a pretty good cut for a defective PT31. I need to get on Amazon and order another one, and so it'll be cutting like it's supposed to be. Now let's try the Vevor with the pilot arc. Okay, so this one is the AG60 torch with the pilot arc, and I want to show you. I'm just going to pull the trigger, and I don't have this connected to the metal, I just want to show you what the pilot arc does. See, that shoots it out without even touching the metal. And that's really handy when you're doing expanded metal, when you're cutting expanded metal. And I'm going to show you a demonstration of that in just a minute. But I have this on the Vevor Cut 50P on 220 volts, and I'm running about 45 amps. I'm going to get my piece of metal here for my straight edge. Let's give this a cut. Like butter. Alright, so now, like the other example, I'm going to take my little hammer and see all this blob down here? That's just dross. D-R-O-S-S. And I'm just going to tap that off with a hammer. See? Nice and clean. And that is buttery smooth. Oh man, that feels good. Okay, so for this expanded metal, again, I've got it on the Vevor Cut 50P, and I'm using the AG60 pilot arc, and I just want to show you how easy it is to cut expanded metal with the plasma cutter with the pilot arc. And if you've ever had to do a bunch of work with expanded metal, you know what a pain it is to use a cutoff wheel on an angle grinder. Well, we're going to simplify that process. Let's get cutting. And there you go. And if you can hear it, there's my compressor kicking on. That thing hadn't come on in a week, and it happens to do it right when I'm doing this example. Well guys, that's pretty much it. I don't know what else I can say. Plasma cutting is pretty simple, pretty basic. Really all you need is the machine and an air compressor that can handle it. And you know, everything else is just kind of up to you. Plasma cutting is easy, it's affordable, it's fast, and you can get into the bigger machines. You can get a plasma table, you know, that you know, cuts things out. Well, I'd love to have one of those, but I can't afford one, so I've got a couple of friends that have one, so I sub the work out to them and just pay them for it. But you know, I really don't come up with that kind of work too often. When I do, it's really not that hard for me to just use the plasma torch handheld and just do it. So, you know, again, if I've left anything out, I apologize. I'm not the be-all expert guru on plasma by any means. I just want to introduce you to it and answer any questions that you may have had that you didn't have anybody to ask. But if I did forget something, and if you still have questions, you know that I love your comments, and I respond to every single comment that comes down the messages. So leave a message below. I will answer it within a couple hours usually. But I'm going to go get some coffee, and I hope you learned something. And if you get a plasma torch, I wish you the best of luck. If you don't have one, I highly suggest getting one. But thanks for watching, and y'all have a great day.